and what your score was. It'll break down the different scores, and then it'll give you a composite score. That's the average of all those scores. All right, let's go ahead and let the bells ring. So these primary sources for this presentation are the Learning Express library tutorials that everybody in South Dakota has access to through the state library. The For the Love of ACT Science, that's a new book I have. It's a very good one. Princeton Reviews, Crack the ACT book, ACT Black Book, and Magoosh. So it's just a compilation of little things that picked up from different places. All right, let's get started. So you're going to have 40 questions in 35 minutes, and there are now 6 passages, and they each have 5 to 7 questions. There used to be 7 passages, and the example we're working on today was from the test that had 7 passages. I think they were a little easier when they had 7 passages, and they're a little bit harder now that there's 6, but I'm giving you an extra one. If you didn't get it, you can come up here and pick one up, and I'll upload it onto the Google Classroom or send it out via email. But anyways, the new one up here has 6 passages, so you can use that one at home to practice on and stuff. But we'll practice today with the one that is already in your book. So you got to allow roughly 5 to 6 minutes per passage. You're probably going to use less than 5 minutes on the ones that we're going to go over the 3 different types they have, and the ones that are data representation, you're going to use probably less than 5 minutes on, so you can save some of those minutes for the ones you actually have to read. Okay? I don't know if I lost some of the Zoomers. I only see one. Does that mean the rest of them are gone?
You have only one showing.
Where do I do that?
It's like hover over the actual person, and then you see and then you can just put.
It won't show them all at once.
No.
Okay, oops, sorry. All right, so some math on the ACT Science, but there's no calculator allowed. It's basically estimating, it's not like you're doing detailed calculations or anything. So unlike with English and math, your knowledge review is not a good use of your study time. There's very little that you need to, and it could be from any topic you've had. And so it's just too hard to try to do that. And it's usually basic information. We'll talk about that. So what you want to do is work on your strategy and your pacing with practice test. And that's what we're going to talk about today. Mostly we will talk just like 1 slides about general knowledge review. And just remember, this is not schoolwork. I know this is hard, especially if you're a perfectionist, if you're a firstborn child, whatever. It's going to be hard to do some of the things we're going to try to do today, like going straight to the questions instead of reading the passage first. And it's going to be hard to realize you don't have to really understand the whole science experiment. You just got to get the answers right. And so basically our job is to locate the answers. So it's like finding where's Waldo. You find your locators and you just try to find the answer. You don't really have to understand the whole experiment. I mean, if it were school, I'd tell you need to understand what's going on, but you don't have time to do that on the ACT test. So I know it sounds like blasphemy, but these first few slides, I'm just giving you some Magoosh videos that are helpful. Like if you feel like you want more about it, you remember there's that link that's called ACT Sources, and it links you to the free Magoosh videos. These are some ones that are handy for the science test. There's one that goes over the different types of questions on the ACT. There's the data representation questions, passages, and there's the research summaries. Those are the ones that say experiment 1, experiment 2. And then there's the conflicting viewpoints, and those say scientist 1, scientist 2, theory 1, theory 2. It's like where there's a debate going on. And those are the hardest for me. All right. The data representation, they are the easiest for me. And they're usually interpretation where you just go find an answer. Like it'll be, what temperature do you get the best results or whatever, and you just go find that answer. There's comparison, like they'll say which fertilizer did better or whatever. And then there's making predictions where you're asked to, the number's not actually on the graph. You either have to interpolate like it's between 2 numbers that are on the graph, or you have to extrapolate out beyond the graph. graph that's there. And when you extrapolate, you just assume that whatever trend's going on there at the end, that it's just going to continue. You can even draw you a straight line out there if you need to. So, because there's no way you could know if there was some wild change that happened. So when you're asked to go beyond the graph, just assume it's going to keep the same trend. And then the harder ones in those, and they're still not that hard, is where you draw conclusions and put it all together. And it might be like, based on table 1 and figure 1 and the experiment, which is the best fertilizer to use if you're wanting to grow tomatoes or something like that. So it's just where you put it all together. You know these because it's mostly tables and graphs. There's very little text in these, and these are the ones that I really, really want to encourage you to start with the questions and don't read the passage. Just start with the questions and find Waldo. Find the locators in the question, and then go find Waldo in the graphs and stuff. So these are ones that are easiest for me, and I do these first because they take the least time for me. And it's all about your individual, you know, everybody's different, but these are the ones that are easiest for me, and I hope they'll be easy for you after we go through this. But like on everything, like on the math and everything, all the questions count the same. So you might as well go answer the easy ones first, okay? Even if they're not presented first. All right, the second type are the research summary. Those are the experiments, as they say, study 1, experiment 1, stuff like that. They have some figures and some text. And they often are trying to test your knowledge of the scientific method. And we're going to review the main things you need to know about scientific method later on. But it's kind of testing if you understand what's going on, like what the control is, what's being measured, what's, you know, what's being changed and stuff like that. And these you usually can start with the questions, and sometimes the last one is harder, the very last one in the science test. And you may have to go ahead and read more in that. It may be a little harder, it may not refer to figures and things as much. So, but most of them you can start with the questions. And then when you have to, go read the text. Like if you can't find it in the graphs, then you can go read the text to find it. And I'm only telling you this, if you had unlimited time, I tell you to read the thing first, but you don't have unlimited time, and you're going to run out of time if you try to read the whole thing and then look at the questions and then go back and try to find the answers. So the last passage often has fewer locators, which is important, and we're going to talk about those in a few minutes. The conflicting viewpoints passages, they are the hardest for me. They're also known as the battling scientist, and it's, you know, scientist 1, scientist 2, theory 1, theory 2. There's lots of text, and they rarely have graphs, and these are the ones you're actually going to need to read, okay? You have to read these if you have time left. I saved this one for last, so I have to look at how much time I have left. I save it for last, and if I have enough time, I read it. And I have had 2 students who did better on these, thought they were easier than the ones with the graphs and tables and stuff. And they were ones that did well on the reading test and did a lot of reading and could read pretty fast. And they just, they really had a hard time with going straight to the questions first. That just felt uncomfortable for them. So they thought these were easier than the rest, but everyone else has found them to be hard, the battling scientist. So we already talked about it. Unlike the others, it's not recommended to skip straight to the questions. So like I said, if you have enough time, if you've saved this to last or next to last and you have enough time, read it and then answer the questions. If you don't have a lot of time left, if you'll read the last sentence of the introduction and then the first sentence of each scientist's viewpoint, you'll at least know what that scientist's main argument is, and then go to the questions and go back, and at least you'll know, you know, go ahead and underline those, that last sentence of the introduction and the first sentence of each scientist's viewpoint, and then start the questions and find your answers. But if you have time, go ahead and read it. And often phrases in the questions are going to have exact matches in the text, so it's just finding Waldo in the text, not in graphs, okay? Oops. All right. So you can practice. We're going to do some practice tests today where I'm going to insist you start with the questions, whether you want to or not, just to see if you can do it and to see if it was a good strategy for you. But if it's not, you can try reading the whole passage first, especially if you are a really fast reader. But if you're not a really fast reader, I really think you'll run out of time. Some people, instead of skipping the passage and going right to the questions. They'll just like skim through and kind of get a layout of where everything's at and then read the questions. But like I said, there's only been 2 kids out of all that I've helped that preferred to read the passage first. So I think for most people, you'll do better if you go straight to the questions, except on the conflicting viewpoints. All right. Here's the thing about the ACT test, the science test. It comes at the end, you're tired, and there's a whole lot of terms on there that you're like, what? I remember something about that, but I don't remember, like, I don't know. And you get all scared because they're using words that you don't remember and that you think you're supposed to know and you don't, but don't do that. Just like, it doesn't matter if you know what that word is or not. You can answer questions about whether it's increasing or decreasing as the temperature changes, whether you even understand what that thing is. So don't let the terms freak you out. They try to freak you out by throwing things at you. And you're really not supposed to know this stuff. It's just the kind of text you're going to be expected to read in college and understand. And they're just wanting to see if you can comprehend what's going on. So don't be intimidated by those words. Just match the phrases and find Waldo. There's a video on that at Magoosh too. I'm going to go ahead and get this out of the way. The science knowledge. So on the ACT test, like 36, 37 of the questions out of the 40, it's in the graphs and it's in the text. 3 or 4 of them will call you to know something outside of what's on the page. The reading test, everything's there. Every single answer that you need to know is found in the passage. So on this, there's 3 or 4 that are not. But it'll be basic stuff. It won't be too complex, and either you remember it and you know what's going on, or you don't, and you take a guess and you just let it go, you know, because you can't possibly study up on everything you've ever learned. So there, but most of the time I think you'll be able to figure it out. And we're going to go over some of that later. I guess I thought the next slide coming up was that. Sorry about that. All right, so look, some tips. Look at the graph names, look at the chart and diagram titles, look at the axes, the left axis, the x-axis and the y-axis, look at the legends. There's usually a little line that you're following on there, and they have different designs on them. We'll see that in a minute, but just look at all those to figure out what's going on, and you're going to look to see if there's a trend. Even if it's in a table, you're going to be looking for a trend, like is this increasing or decreasing as they change something else. So there's some Magoosh videos on that. There's Magoosh videos on pacing and finding the clues. So those are good ones to watch too, and they're free. So our first clues, our first locators, they're going to be found in the question. So if the question says figure 1, figure 2, or table 1 or table 2, make sure you go to the right place. And make sure if it says figure 1, you go to figure 1, not table 1, because sometimes you get confused and go to the wrong thing. So that's your first locator is, what table is it referring to you to? And if it says based on the results of the study, when it talks about the results of the study, you're going to look at the data. That's also going to be talking about, your answer is going to be in the tables and graphs. But if it says according to the information provided, or according to the passage, or based on the passage, that's when you know you're going to have to look in the text and not just in table or graph. And if it says based on the study, you could look either in the text or the data, because it's just, it's not referring you to any specific place. But the second clues, and you look for these in the questions first, and then you look in the passage. The second clue in the question is going to be your units that they give you. If it says, based on table 1, does the RPM increase or decrease as you change the fuel to such and such? So you can even circle them, like circle it in the question, circle it on the table if you want to. But so after you look for the figures and tables or where you're going to find it, then you look for the units, look for the labels of the charts, and you look for scientific terms like pH, protons, any phrase that kind of pops out in the question. That's where you're going to be, that's the Waldo you're going to be looking for in the passage. All right, and sometimes you can look at the actual answer choices to finder locators, like it may start referring, all the answers have one thing in common, and it wasn't a word used in the question, but it's in every answer. So that's also a clue that you're going to look for that word over in the passage. All right. How am I supposed to get that thing on? I don't even know. It says to move it away, but I can't. Sorry if you don't know what I'm talking about. It's on my screen. All right, trends and tables and figures, just like we talked about, even if you don't know the term, you can tell if it's going up or down. We've talked about extrapolating outside the chart. We've talked about interpolating, and it won't ask, it's not like when you're interpolating between two numbers, it's not going to be something you really need to do with a calculator, or even you're just looking for an estimate. Like there's going to be an answer that's definitely in the range you're looking for, and the others are not going to be in that range. So it's not, don't do a lot of figuring that you don't have to do, just kind of estimate. And sometimes as far as trends go, there is no general trend, like something may go up and then go down. And so there is no correlation between the two, and that's okay. And that'll be an answer choice that's there. So don't make it be a trend if there's not one, because sometimes it'll just say there's no consistent relationship or something. So here we're going to practice a little bit, and like, I don't know Kelvin temperature or anything like that, but I don't need to. I just need to answer the questions. So which one of the metals listed? So right across the top here, this is temperature, these degrees up here, and these are the elements. Which one of the metals listed has the highest thermal conductivity at 300 Kelvin? So our Waldo's 300 Kelvin, we go down 300 Kelvin. What's the answer? Copper, right. All right. At what temperature does gold have the highest thermal conductivity? So this time we go to gold. What? 100. All right. Now these are just those ones that we would call an interpretation. So these are the easiest kind to me. So how does the thermal conductivity for aluminum change in the range of temperatures given? We're going aluminum, the temperature is going up. What's happening with aluminum? Oh, sorry. Yes, decreasing. So we don't have to know much about this, and we can answer those kind of questions. So, all right, this solubility, I'm like, when I read solubility, I'm like, oh yeah, I don't remember what supersaturated and all that stuff means, but let's still just answer questions. Okay. A supersaturated solution is defined as one in which the amount of solute dissolved, solute means like your salt or whatever, exceeds solubility at a given temperature. All right, so a solution, this would be given in the text. And the question, a solution of sugar in water is not supersaturated when 300 grams of sugar and 100 grams of water are mixed at a temperature of, so we're looking at the grams, wanting to know the grams. And when we look over here at our chart, this is the grams of sugar per 100 grams of water, just like in that question. So we're looking at the 300 over there. I don't know where my little, so when is it not supersaturated? And it'll always, the knots will be in capital letters. Like, I can't get my little pointer. Oh, there it is. So we're looking at 300. Let's go out here and let's just draw the line. Do this on your test. Draw your line straight out. And so then the answer choices are 20 degrees Celsius, which is right here. 40 degrees Celsius right here. 50 degrees Celsius right here. And 70 degrees Celsius over here. So which do you think is the answer choice? You know, even if we still don't understand what's going on, 3 of those answer choices are below the line and only 1 is above the line. So what would you guess? What? D, right. So sometimes even if you don't understand what's going on, if you've drawn your line or whatever, and it's the one that's not like the rest of them, okay? Because they can't all be right. All right, so. All right, what is the, this is a comparison question where you're asked to compare 2 different things. What is the approximate difference in temperature for the solubility limit of 200 grams of sugar per 100 grams of water and 250 grams of sugar? So we're looking at this line, we're looking at this, and we're looking at this, and they said the difference. So when we see the difference, what do? Subtract. So They want to know the difference in temperature. So one is here and one is here. So what's the answer? So one's 40 and one's 0. Right, okay. All right, and here's where we're asked to make a prediction. This one is asking you to extrapolate beyond the graph. So at 100 degrees Celsius, we're looking right out here. So you can draw these lines on your chart. It may help you. The solubility of sugar in water would most likely be, and there's your answer choices. And you can just draw a straight line, and I can't draw. So, but the answer choices, a lot of times on the ACT, if you look at the answer choices, they really are easy, just like these down here, because there's one that says less than 250, and less than 250 is already out here. And there's one that says 250 to 350, and that takes us to there. There's one that says 350 to 400, and we'd get to there to 400 at about there. So which one do you think it is? G, more than 400. And see how you didn't have to come up with an exact number, so you don't need to like do more math than you need to. You just got to estimate where it's going to be. All right, and here's one that asks you to draw a conclusion based on the information. You just put it all together, sum it up, and decide what would be a good idea. So if you were looking for a metal whose heat transfer properties didn't vary much over a wide range of temperature, which metal would you use? You just look in there and see which has the least variability. So if I were looking at that, a quick way is to look at the highest and lowest. So this one goes from 300 to 232. This one goes 483 to 383, 345 to 304, 132 to 55, and 79 to 72. So which varies the least? Platinum, right? And you don't need to waste time like getting these exact numbers, like subtracting 232 from 300. Just kind of look at it and estimate. If you do have to, you know, get deeper, you can, but try to do it the easy way first. You know what? This did not have, this is not actually the right PowerPoint. It didn't have some things I added yesterday. So hold on a second. Now I'm gonna stop recording. Okay, let's try to find that test. And I think you guys can see it now. So don't get intimidated by all these scary looking, like, I mean, that's a chart like you don't normally see in your science classes, but when we go to it, you'll get it. But so passage 6 is the one that's the conflicting viewpoints. You can see that there's no graphs. Student 1 and student 2 each have arguments, and it's one of those you're going to have to read. So that's not the one we're going to do first. Which one do you guys want to do first? And we're going to set a timer and see how long it takes you to do. But which one do you think looks the easiest? Passage 1. Okay, if you go to passage 1, it's about flood basalt plateaus. And I'm like, you start freaking out and thinking, I don't even remember what basalt means and a plateau and all that stuff. So, but I challenge you, you're not going to get to read this. I want you to go straight to the questions and try to do it just by looking up your locators, and then we'll go over it. But we're going to set a timer, and I'll just look and see when everybody's done, or I think the Mac, I'll just set it for 6 minutes. And if everybody's not done by 6 minutes, we're going to go over it anyways. Okay. You ready? Start with the questions and go. Okay, let's go over them. All right, did you find it hard to start with the questions, or did you find it easier? Okay, all right, and you realize that a whole lot of that stuff there, you don't even need to know or understand to answer the questions. So, all All right, let's look at question 1. In the plume model in study 1, there's our locator. If the plume model in study 1 is typical of all mantle plumes, the scientist would generalize that the heads of plumes are what? The heads are approximately twice the diameter of the tail. So like, how easy was that, right? So that's not hard. All right, so the scientist in study 3, so that's a locator. We know that some of the information we may need is there, but they hypothesized that the larger the volume of lava produced, the larger the number of marine organisms that would become extinct. If this hypothesis is correct, the formation of which of the following plateaus caused the largest number of marine organisms to become extinct? So to start with, I thought we were going to be looking in study 3 for our answer, but then when you look at the answer choices here in F, G, H, and J, you're going to have to look for where the plateaus are listed, and that is in table 2. So what's the answer? What'd you get? J. Okay, right. So one of our main locators in this one was in the answer choices. So, all right, based on the results of study 2, a flood basalt plateau that produced lava for a period of 1.8 million years would most likely have a lava volume of, this is one where you have to interpolate. So what did you guys get? You got D, right, over 2,125,000, whatever those are, kilometers cubed. All right, good. All right, let's go to number 4. And if anybody has questions on any of these or got confused and had a different answer and want to, talk about what confused them, we can. All right. Oh, this is one of the types of questions they have that I didn't go over because my slide's not there. I'll try to find it when you guys are taking the next one. But there's usually these yes, yes, no, no, or this answer because of this. There's these questions that have 2 parts, and you got to figure out what's the right answer plus why it's the right answer. So this is kind of one of those questions. According to study 2, which of the following statements best describes the relationship, if any, between the age of a flood basalt plateau and the length of time lava was produced at that plateau? So we're looking at the age and we're looking at the length of time. So those are our 2 Waldos there, 2 locators. So what did you get for your answer? J, right. There's apparently no relationship between the age of a plateau and the length of time lava was produced. If as one got larger, the other one did too, then, you could have said increases, but that some went up, some went down. So good job. All right, so which of the following graphs best represents the relationship between the age of a flood basalt plateau and rate of lava production? So once again, we're looking at this one that has the age and the rate of lava production. So which picture did you choose? B? Right, okay. And then number 6, it's one of those extrapolating ones. If the hypothesis made by the scientist in study 3 is correct, evidence would most likely be found of another extinction of marine organisms that occurred around G, right. So, because if you look, the guy in study 3 hypothesized that, or he talked about how they went extinct around 58 million years, which right before 60, around 66, which is not long before 67, and around 133. So yeah, you'd expect the other one to be somewhere around the 192 marks. All right, good job. So the thing is, on those, you need to try to get those done quickly, because if those take you the whole 6 minutes, it doesn't come the first time that you're doing. This is practice. So if those take you the whole 6 minutes, you aren't getting the bank time for the ones that are going to take longer. So what I want you to do as you do these is time yourself on them as you do the ones we're doing today, and as you do if you do any in the little packet I'm sending home with you. Time yourself and write how long it took you on each one, and then go look over that and see if you can figure out which kinds are the easiest for you, so you'll know which kinds to tackle first. Okay. All right, let's just go ahead and do passage 2. Time yourself and write your time up on the thing. If you guys all have a clock, and I'll set this again at 6 minutes. All right, are you ready? So fun. They are kind of fun if you just start thinking of them as you're finding clues and just like it's a race, you're finding clues, you're finding Waldo, you're marking it and you're moving on, okay? Don't try to comprehend everything that's going on. Don't comprehend unless you have to. Some questions, there'll be some later passages and just some late, they kind of get harder as you go along in a passage too. So sometimes you'll have to comprehend something, but don't comprehend any more than you have to. All right, let's go. All right, everybody's done here in the room, so we're going to go ahead and go over these. All right. What did you get for number? Let me see what number that is. Mine's off the. Okay, number 7. D, right. According to figure 1, the end of the year 50, the net productivity of the land was closest to D. Good job. All right, what did you get for number 8? F, all right. So some of these are ones that shouldn't take you long at all. They're kind of at a glance thing and you find them and you move on and save your time for something else. So that's kind of an at a glance one. And what about number 9? C, right. When you hear a question that talks about the most change or the largest change, the biggest increase, whatever, look for the part of the graph that's the steepest, and that would be C. So that's another at a glance kind that shouldn't take you a lot of time. You can bank it for something else because there will be ones that take you time. All right, what about number 10? This is one that I had trouble with the first time. So when you're asked something and you can't quite figure it out, there may be a legend or a part that you've not noticed yet. And that's the case for this. There was a legend that I hadn't noticed yet on this one. So what did you get for 10? Did anybody else not notice those stages that said herb tree to start with? Or did you notice them right away? I had totally not looked at them until I was like, how am I supposed to know that? And then
Which one was it?
It's J. So if you look under the graphs, there's these stages that show herb, shrub, and tree. So that was a part of the graph I hadn't seen yet the first time I looked. All right, and then number 11. This is the first time we're even asked to go use table 1. So what'd you get on on number 11?
C.
C, right, shrubs. Because if you go and look, eastern meadow, large yellow throat-billed sparrow, they are all in the shrubs section. Did anybody need any of those explained?
So for like 10, when it says like the highest productivity, does that mean like the highest number on the left side, where it's like
It's where the
1,200?
yeah, it's the highest number over there. That's net productivity. That's your label over there. So it's going to be where most of the line was high, where the line was highest.
Oh, okay, because I didn't know if it was when it went up the fastest.
No, that's when it changed the most, when the most growth occurred. I mean, when the most change occurred, but the net productivity was the highest. But like the other one we were asked before, when it increased the most, during what period, that was the answer about when it was the steepest. Okay. All right, before we go to the next one, I just want to go over a few things about scientific method since I seem to have lost that slide. I must have put an old version of my PowerPoint on here and I didn't have the part about scientific method. So in a scientific method, your independent variables, those things that are that you're changing, they're found on the x-axis. They're found in the leftmost column of the table, and that's what you change. What you measure, the dependent variable, is what you're measuring. It's in the rightmost column of the table, and it's on the y-axis. So that's where you find those things. And the constants are the things that are not being changed in the experience. And then there's usually something called a control. So if you have a question about a control, it's one that was in there just to measure against to show what happens if you do nothing, or what happens if you don't add this fertilizer or something like that. So does that make sense? You just kind of understand the independent things, what's changing, what's measuring, that your controls, what you're comparing it to. All right, so do you guys want to try this next one? It has lots of cool little drawings. Passage 3, this is our first research summary. So if you'll notice, this one has text and graphs and figures and drawings and stuff. So let's just give her a try. This one might take you longer. You what? Now, sometimes you do have, if you can't find it without reading, then by all means, go find your Waldo in the text and read the text around that Waldo, okay? All right, you guys ready? Let's go. All right. Everybody ready? We'll look over these. Was this one harder?
Yes.
Had more things going on, didn't it? All right, let's look at the questions. In experiment 2, at which of the following temperatures did all of the liquids tested have the same volume? So we're looking at where experiment 2. And so here's the graph we're going to look at. When did they all have the same volume? Right, at 20 degrees, so F. And anytime you want to discuss anything, we're not in a hurry, so we're just practicing. And if you have a question, somebody else probably does too. All right, here's one of those yes, yes, no, no's. I had one of the smartest kids I had worked with on this ACT prep. He just hated those yes, yes, no, no questions. But, so everybody has their thing they are better at and worse at. So a scientist has hypothesized that as the temperature of a gas is increased at constant pressure, the volume of the gas will also increase. Did the results of experiment 3 support his hypothesis? What'd you get? A, yes. So sometimes you can figure out the yes part or the no part and then look at the reasons why. And often they're just the opposite. One is the direct opposite of the other. But sometimes it's easier to look at the second part and figure out the why and go answer the first part. So you can do it different ways. But yes, the volume of all the gases tested in experiment 3 increased as temperature increased. Good job. All right, 14. Based on the results of experiment 1, so it says based on the results, we're looking in the data. If an engineer requires most resistance to stretching when it is placed under tension and heat, which should he choose? She choose. J, nickel. Okay. As you see nickel on the graph down there, it's at the lowest. So what you have going on in this chart, we look at the axes as the temperature goes higher, then the linear expansion goes up over here, and nickel went up the least compared to all the others. All right. Number 16. The scientists tested a copper wire of the same initial length as the wires tested in experiment 1. So we're adding something in. We're going to interpolate on this one. At 80 degrees Celsius, the linear expansion of the wire was 0.12 millimeters. Based on the results of experiment 1, which of the following correctly lists 5 wires by their length in the apparatus at 80 degrees Celsius from shortest to longest? Okay, make sure you don't answer the way from longest to shortest, but from shortest to longest. So it said it's at 0.12, so it's going to go about right there. So which shortest to longest is what? H, right. Nickel, it'll be there. So nickel, iron, copper, brass, aluminum. Okay? Yeah. All right. Based on the results of experiment, okay, so if a balloon was filled with air at room temperature and placed on the heated water bath, as the temperature of the water increased, the volume of the balloon would, yeah. So we are looking at, the results are shown in figure 3. So if you look at figure 3 up there, you'll see that all three of them are on that line. It says air, nitrogen, and methane. So they all went up as you go across the chart. As the temperature increased, the volume of them all increased. It's not in that first little picture. The first little picture doesn't tell you anything, but that figure 3 does shows you that the volume went up as the temperature went up. Does that make sense? That makes sense now?
Oh, no, we just skipped it. We never did it.
Oh, okay.
No, yeah.
Okay. Oh, I thought, sorry. I can't tell where I'm going up and down on here. Thank you. All right. 17. This one, you got to use a little logic. So if experiment 1 had been repeated using a heavier weight attached to the brass wire, which of the following figures best shows the comparison between the results of using the heavier weight and the original weight on the brass wire? Which one do you think? D. Okay. Look at, so C shows the original weight. So if you've got, what we're testing here is how much something stretches or expands. So if you have something hanging on something else, if something heavier is put on it, it should stretch more than the lighter weight with the lighter weight. So D has the heavier weight having a higher expansion or stretch than the lighter weight. Does that make sense? That's one that I wasted time on, because if I'd have just used logic, I could have answered it, but then I went and had to read what was going on. But
Was it D?
it's D, yes. I went and read what was going on and kind of lost some time there. All right. The next one is just a data representation passage. It has a lot going on in this graph, so I think it's good to look at ones where you got to look at things, not just the x-axis and a y-axis, but kind of everything going on in this whole big old chart. So let's try it, but it's only got a few questions and we'll start the timer on that. You ready? Isn't this fun? No, it's not as scary as I thought before I went and took the first test. I thought it was going to be about all the knowledge I'd gained through the years, and I hadn't even had chemistry yet, so I thought it was going to be awful, but I really did better the first year I took it and hadn't had chemistry than the next year when I had chemistry. So ready? Go. All right, let's review this one. All right, so basically, I don't know, if you did go look at the text, the only sentence that really helps you out is that first one that tells you what's going on, that there's certain wavelengths of solar radiation. The rest of it just describes this, this chart, what all was being measured. So let's go to the questions. According to the data provided, at what altitude is the upper boundary of the thermosphere located? So we find thermosphere at J. The upper boundary is not included on the figure. So any of the other boundaries we would have had, other years we would have had a boundary, but that one's not shown. All right. The ozone layer selectively absorbs ultraviolet radiation of 2,000 to 3,000 wavelengths. According to this information and the data, which atmospheric layer contains the ozone layer? Looks like it is, yes, B. Did you guys say B or D? B, okay, all right. All right, the information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following wavelengths of energy? F, 1500, right. So looking in the I got to scroll down, make sure I'm not missing a question there. Right. All right, on the basis of the information in the figure, one could generalize the atmospheric pressure. So we're looking here this time. Atmospheric pressure in each atmospheric layer increases with what? C, with decreasing altitude. Because unlike in normally, you know, things go up as you go up a scale, but this one is going down. So as the altitude is going down, the atmospheric pressure is going up. So yes, All right, and then number 22. Atmospheric boundaries are at a higher altitude. So this is one of those putting it all together things. Atmospheric boundaries are at a higher level than usual altitude above areas that get more direct solar radiation. So they're hotter. So based on this information and the data provided, which of the following predictions about atmospheric boundaries would most likely be true if Earth received less solar radiation than it presently does? So if it were cooler than it normally is. So which one? G? The tropos, yeah, right. The boundaries would all decrease in altitude if we got less solar radiation. So that's just one of those putting it all together ones. All right. We're going to skip that next one because I'm afraid if some of you guys are wanting to leave, I want you to at least have done a battling scientist one where you have to read it. And I'll set the timer for 7 minutes on this one in case it takes you longer. But if you're bumping up against the 6 minutes every time, you're going to need to work on your timing because there's 6 passages. And if you're bumping up against 6 minutes every time, that means it would take you 36 minutes and you're only allowed 35 minutes. But some passages are harder for different people than others. But so you're going to need to work on getting those that are easier for you, getting them done as fast as you can, without making any mistakes. But this one, since you have to read it, I try to save all the time I can for the conflicting viewpoints, and usually the very last passage is hard for me. And I do want to say something in case you guys leave later. The test I sent home with you, you'll find it's harder. I think the test got harder when they switched to 6 passages instead of 7 because there's more questions in each passage and they get a little more in depth. But they do, like I've told you before, there is this curve. So if you get I heard the last test in October had a really hard science section. That's what they were saying on an ACT forum that I'm on. But then they give a bigger curve when all the kids are doing worse on it. So just remember, if you took a science test and you're like, wow, that's way harder than anything I've ever seen before, just realize that the curve will be better when it's a harder science test. But the one I'm sending home with you is a little harder, but you can still do it. Just look for Waldo, okay?
Which one are we doing?
We're doing the number the conflicting viewpoints where there's the battling scientists, student 1 and student 2. Okay, this is one you do have to read, of course. So read it first and then go answer the questions and go. Okay. Did anybody find this easier, or did you like it better or worse? Was it easier for anybody? Okay. Every now and then somebody thinks those kind of are easier. So, all right. And did it take you longer, or did you do it in less time than the others? Did you time it? Okay. All right. So 28, according to student 1, which of the following quantities is less for the gases from burning wood than for the air that surrounds the fireplace? Oh, wait, I want to do one thing first. You know how we said if we were running out of time, read the let's just see what we know if we read the last sentence of the introduction. It says, they also discuss how chimney efficiency, the volume of smoke flowing out of the top of the chimney per second for a given temperature difference inside and outside the chimney is related to chimney height. And then we read the first sentence of student 1. Smoke rises because the gases from burning wood are less dense than the air that surrounds the fireplace. We'll read student 2. Smoke rises because wind blows across the top of the chimney. So we know that one is saying that it's about the density of the gases, and one is saying it's about the wind blowing across the top of the chimney. All right, so according to student 1, which of the following quantities is less for the gases from burning wood than from the air that surrounds the fireplace? Is it the average speed of the molecules, the distance between molecules, the density, or the temperature? What? Density, right. The density. All right. When wood was burned in 2 fireplaces that differ only in the height of their chimneys, keeping the same temperature difference between inside and outside each chimney, chimney Y was found to be more efficient than chimney X. What conclusion would each student draw about which chimney is taller? B, both students 1 and 2 would conclude that chimney Y is taller. This is found directly in the text. One says as chimney height increases and efficiency increases, and the other says as chimney height increases, efficiency increases. They have different reasons for that, but they both agree that it does increase. All right, which student, if either, would predict that smoke from burning wood will rise up the chimney from a fireplace on a day when the air at the top of the chimney is not moving? F, student 1 only. All right, when wood is burned in a fireplace, air in the fireplace, as well as gases from the burning wood, rises up the chimney. Student 1 would most likely argue that the air in the fireplace rises because the air is hotter than the gases from the burning wood, cooler than the gases from the burning wood, hotter than the air that surrounds the fireplace, or cooler than the air that surrounds the fireplace. C, right, hotter than the air that surrounds the fireplace, because we are talking about the gases from the burning wood. All right, when the air inside a particular hot air balloon cooled, the balloon and its inside air descended. Based on student 1's explanation, the reason the balloon and its inside air descended is most likely that H, and this can be found. The downward force of gravity acting on the balloon and its inside air was stronger than the upward buoyant force acting on the balloon and its inside air. So you can eliminate some of these just by looking, like buoyant force is not a downward direction. So you could eliminate that one just seeing those first few words. And then you could eliminate J by seeing those first few words say upward force of gravity. So then the only two you'd really be looking at are G and H. And it talks about it right here, word for word, upward buoyant force and the downward force of gravity. So it's found right in the text, okay? Based on student 1's explanation, if the gases from burning wood lose heat while rising up a chimney, which of the following quantities pertaining to the gases simultaneously increases? Which one? The density of the gases increases, yes, because they're not as spread apart, they're not as speedy, they're all that. So based on student 2's explanation, the reason the wings of an airplane keep the airplane up in the air is that air moves at a higher speed, F, right, above the wings than below the wings. All right, so you guys did good on that. All right, I wanted to just talk a little bit more